Hello students, welcome to my MacPhi channel. Today we will go through chapter Gravitation. Sir Isaac Newton, the famous physicist and mathematician, discovered some laws to define force, to measure force, action-reaction pair of forces, as well as universal law of gravitation. According to universal law of gravitation, in our universe, every object attracts every other object by an amount of force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So, if two objects having masses m1 and m2 are kept at a distance d unit between them, then according to universal law of gravitation, if that is gravitational force is directly proportional to m1 into m2 and inversely proportional to the square of the distance between them. So, F is equal to one proportionality constant, that is capital G, and m1 into m2 by d square, where G is called gravitational constant or universal constant. Now, why this law is called universal law? Since this law is applicable for any objects, whether it is big or small, whether it is terrestrial or celestial object, so it is called universal law. This law is also called inverse square law, since the gravitational force is inversely proportional to the square of the distance between them. Now we have to have clear idea of how to measure distance. Distance is actually the distance between center of masses of two objects. Then what is center of mass? Center of mass is mean location of distribution of masses in space. What does it mean? Let us consider spherical object. The geometrical center of that spherical object is center, and around center all masses are equally distributed. So in case of spherical object, its geometrical center is called center of mass. Why? Because this is the location, mean location of distribution of mass in space. Similarly, in case of triangular object, centroid is defined as center of mass. Now in relation, we have to know what is center of gravity. Center of gravity is a hypothetical point in an object through which total weight of the body is thought to be concentrated. So you can say center of mass, that point into G, is called center of gravity. Okay, we will discuss what is importance of law of gravitation, but we can say gravitational force. It is the force which binds us to the earth. Due to this force, planets are orbiting around the sun, and also moon is orbiting around the earth. The tides due to moon and due to sun are also due to gravitational force. Now we will discuss two forces which are based on gravitational force. One is centripetal force and the other is centrifugal force. What is centripetal force? When a body is in circular motion, then one force always acts along axis of rotation towards the center of rotation. This force is called centripetal force, and value of this force is minus mv square by r. What is centrifugal force? It is a pseudo force which always acts away from center along the axis of rotation, and mathematical value of this is mv square by r. And third force, which is called force of inertia, always acts along the tangent of the circular path. Okay, now we have to know what are differences between centripetal and centrifugal force. Now, what is centripetal force? Already discussed. It acts along axis of rotation towards the center of rotation. It acts along axis of rotation away from center. Centripetal is radial force. Centrifugal force is pseudo force. Centripetal force value of centripetal force is minus mv square by r, and value of centrifugal force is plus mv square by r. Example of centripetal force, satellite orbiting a planet, and example of centrifugal force, mud flying off the tire. Okay. Now we have to know what is capital G, that is definition of capital G, and also its SI unit. From Newton's law of gravitation, it is already known to us F is equal to capital G into m1 m2 by d square. So by cross multiplication we can say G is equal to F into d square by m1 m2. So if d is equal to 1, m1 m2 both is equal to 1, then G will be mathematically equal to F. So we can we can define in words, that is capital G is equal to force of gravitation between two objects of mass 1 kg which are separated by a distance of 1 meter. So now we have to find out what is SI unit of capital G. Since SI unit of force is Newton, SI unit of distance is meter, and SI unit of mass is kg, so SI unit of G is Newton meter square by kg square. Who discovered it? Henry Cavendish found out value of G as 6.67 into 10 to the power minus 11 Newton meter square by kg square, which is universal constant. Now we will discuss force of gravity. What is force of gravity? When mass of one object is very high with respect to mass of other object, then the gravitational force between them is termed as force of gravity. Let us take an example of an object mass MO is lying on Earth's surface of a mass M suffix E, capital M suffix E, and distance between their center of masses is approximately is equal to radius of Earth. Because since radius of Earth is very large or high with respect to radius of the object, so mathematical expression of gravitational force between Earth and mass of object is F is equal to capital G into ME into MO by RE square. This gravitational force is termed as force of gravity since mass of Earth is very high with respect to mass of object. Okay. Now what is relation between inertial force and gravitational force, and how we will get acceleration due to gravity from this relation? Let us take that object MO which is having acceleration G. Why? Because by Newton's second law of motion we know force is equal to mass into acceleration, which is called inertial force. Since inertial force and gravitational force both are acting together, so we can say F is equal to m0 into z plus is equal to g into MO divided by RE square. MO and MO will cancel out, so g, that is acceleration due to gravity, is equal to capital G into mass of Earth by divided by radius of Earth ka whole square. Now since these three are constant, so we can say acceleration due to gravity on Earth's surface is a constant quantity. How? What is the value of that constant? Small g is equal to 6.67 from here, 6.67 into 10 to the power minus 11 into mass of Earth is 6 into 10 to the power 24 approximately, and radius of Earth is 6.4 into 10 to the power 6 approximately. So radius of Earth square is equal to this whole square. Calculating this, we are getting acceleration due to gravity on Earth's surface is equal to 9.8 meter per second square. So on Earth's surface it is a constant quantity. Okay. Now let's see how acceleration due to gravity varies with an altitude. We already know acceleration due to gravity on Earth's surface is equal to capital G into mass of Earth divided by radius of Earth whole square. But acceleration due to gravity at an altitude is equal to G into ME divided by RE plus H whole square, where RE plus H is the distance between center of masses. So we can say G at H means acceleration due to gravity at an altitude is inversely proportional to 1 by RE plus h whole square. That implies if h increases, acceleration due to gravity decreases. So it implies acceleration due to gravity on Earth's surface is greater than acceleration due to gravity at an altitude. Similarly, by using the formula effective mass of Earth is equal to density of Earth into volume of Earth, we can also show it also decreases with depth. Not only that, since acceleration due to gravity is a vector quantity, when the object is brought to the center of Earth, it becomes zero. That implies acceleration due to gravity on Earth's surface is greater than an altitude and also greater than acceleration due to gravity at a particular depth. So GS is maximum. It decreases with altitude, is decreases with depth also. Now let us consider shape of Earth. Earth is not perfectly spherical. Rather, radius of Earth and equator is greater than radius of Earth at pole. Since acceleration due to gravity is inversely proportional to the square of the distance between them, so from this expression we can say acceleration due to gravity at equator is less than acceleration due to gravity at pole. Okay, understood? Now let's see how acceleration due to gravity varies with an altitude. We already know acceleration due to gravity on Earth's surface is equal to capital G into mass of Earth divided by radius of Earth whole square. But acceleration due to gravity at an altitude is equal to G into ME divided by RE plus H whole square, where RE plus H is the distance between center of masses. So we can say G at H means acceleration due to gravity at an altitude is inversely proportional to 1 by RE plus H whole square. That implies if H increases, acceleration due to gravity decreases. So it implies acceleration due to gravity on Earth's surface is greater than acceleration due to gravity at an altitude. Similarly, by using the formula effective mass of Earth is equal to density of Earth into volume of Earth, we can also show it also decreases with depth. Not only that, since acceleration due to gravity is a vector quantity, when the object is brought to the center of Earth, it becomes zero. That implies acceleration due to gravity on Earth's surface is greater than an altitude and also greater than acceleration due to gravity at a particular depth. So GS is maximum. It decreases with altitude, is decreases with depth also. Now let us consider shape of Earth. Earth is not perfectly spherical. Rather, radius of Earth and equator is greater than radius of Earth at pole. Since acceleration due to gravity is inversely proportional to the square of the distance between them, so from this expression we can say acceleration due to gravity at equator is less than acceleration due to gravity at pole. Now let's see what are the differences between capital G and small g. First, definition. Capital G is gravitational force that exists between two objects of mass 1 kg kept at a distance of 1 meter. But acceleration, small g is acceleration by which a body moves towards Earth's surface. Capital G is a scalar quantity, small g is a vector quantity. Capital G is constant but small g varies. Capital G can not be 0, small g can be 0 at center of Earth. Its unit is Newton meter square by kg square, whereas unit of small g is meter per second square. Capital G value of capital G is 6.67 into 10 to the power minus 11 Newton meter square per kg square, whereas the value of small g is 9.8 meter per second square on Earth surface. Okay, what is meant by free fall? When objects are falling towards Earth's center due to its gravitational pull, then we can say objects are in free fall. During free fall, three equations of motion slightly change. First equation of motion, V is equal to U plus GT. Second becomes H is equal to UT plus half GT square. And third, we write V square is equal to U square plus 2GH, where U initial velocity, V final velocity, G acceleration due to gravity, and H height from Earth's surface. T is as well time taken. Now, here are some tips to solve problems. If a body is dropped or falling from a height, then initial velocity is taken as 0. That is, U is equal to 0. When a body is falling, during that time, acceleration due to gravity is taken as plus 9.8 meter per second square. In upward journey, when a body is thrown upward, then acceleration due to gravity is taken as minus 9.8 meter per second square. At maximum height, when a body is thrown upward, at maximum height, final velocity will be 0. Time required for upward journey should be is equal to time required for downward journey. Am I clear? Now we will discuss what are the differences between mass and weight. Definition of mass. Mass is the amount of substance contained in a body or in an object, whereas weight is the force by which Earth attracts any body towards its center. Mass is a scalar quantity, whereas weight is a vector quantity. SI unit of mass is kg and SI unit of weight is Newton. Mass of a body can never be 0, but weight of a body can be 0. As for example, at Earth's center or center of Earth, weight of any body will be 0 since Z, that is acceleration due to gravity, is 0. Now, mass is denoted by M and weight is denoted by W is equal to M into G. Mass is measured by physical balance, whether weight is measured by spring balance. Okay. Now we are going to solve problems. First, problem 1. If mass of moon is 7.36 into 10 to the power 22 kg and radius is 1.74 into 10 to the power 6 meter, then find acceleration due to gravity of moon. We know mathematical expression of acceleration due to gravity is equal to gm by r square. So putting value of moon, mass of moon as well as radius of moon, we are getting 6.67 into 10 to the power minus 11 into 7.36 into 10 to the power 22 whole divided by 1.74 into 10 to the power 6 whole square. So we are separating decimal points. We are getting 6.67 into 7.36 whole divided by 1.74 into 1.74, and power of 10, we are when calculating it is, we are getting 10 to the power 22 for this, 10 to the power minus 11 for this, and this when come in numerator will be 10 to the power minus 12. So as a whole it becomes 10 to the power minus 1, and this after taking approximation, the point will cancel out, points will cancel out. We are getting 67 into 74 divided by 17 into 70. After calculating this, we are getting 16.3, which is equal to 1.63 meter per second square. So acceleration due to gravity of moon is 1.63 meter per second square, which approximately is equal to 1/6 of acceleration due to gravity of Earth. Am I clear? Now problem 2. A body weighs 120 Newton on Earth's surface. At what height above Earth's surface the body is lifted to weigh 30 Newton? That is 1/4 of original. We know weight on Earth's surface is equal to mass into g on surface, and weight at an altitude is equal to mass into g at that altitude. So weight on surface by weight on altitude is equal to mgs by mgh. Mm will cancel out, is equal to gs by gh. Acceleration due to gravity on Earth's surface is inversely proportional to the square of radius of Earth, and acceleration due to gravity at an altitude is inversely proportional to square of radius plus h, and so you can write 120 by 30, that is 4, is equal to re plus h by re whole square. by square rooting, we can write RE plus H by RE is equal to 2. So RE plus, by cross multiplication, RE plus H is equal to 2RE. So H is equal to 2RE minus RE. That is 6400 kilometer. That implies when a body is lifted 6400 kilometer from Earth's surface, its weight becomes 1/4 of the original. Problem 3. A ball is dropped from a height of 20 meter. At the same time, another ball is thrown vertically upward with a speed 20 meter per second. When and where two balls meet? Since at the same time, so let after t second and traveling x meter from top, two balls meet. Okay, for ball 1, time taken is equal to t, initial velocity is 0 since it is dropped, acceleration is equal to x plus g, that is acceleration due to gravity since it is falling towards earth. Let distance is equal to x. From second equation of motion, h is equal to ut plus half gt square, we are getting x is equal to 0 plus half gt square. That implies x is equal to half gt square. Now for ball 2, since it is thrown vertically upward with a speed of 20 meter per second, so we can take time taken is equal to t second, u is equal to 20 meter per second, and since it is thrown upward, acceleration is equal to minus of g, and distance is equal to, since it is total 20, it is x, so this will be 20 minus x. So from second equation again we can write 20 minus x is equal to 20t minus half gt square. Now to half gt, x is equal to, from equation 1, x is equal to half gt square. So 20 minus half gt square is equal to 20t minus half gt square. They will cancel out. So 20t is equal to 20. That implies time taken to meet is equal to 1 second. So by putting time taken is equal to 1 second in equation 1, we are getting x is equal to half gt square. So x is equal to 9.8 by 2 into 1, that is 4.9 from the meter from the top. So the balls will meet 4.5 meter on the top, from the top, and after 1 second. These are the basic concepts of gravitation. For other chapters, please watch next videos. Till then, bye bye.